Although he's over 5,000 miles away from his head office in San Francisco, Bank of America employee Jerry Van Atter has to keep in daily contact. Sending letters is too slow, and because of the 8-hour time difference, phoning from London during their working hours is inconvenient. And the person he wants could be out of the office. The answer for Jerry, as you might expect, is to use his microcomputer. Jerry makes a phone call to his London office and connects his own micro to the phone using an acoustic coupler. He is then linked to the head office computer in San Francisco, which he can use as a kind of mailbox where messages can be left, providing he knows the right password.
Now, I've now told the computer, hopefully properly, that I want to index the messages that are there. And now it'll tell me that I've got 4 messages and who they're from. And I can selectively read any one of them. I can save them on my own disk and print them out here if I want to, store them here for later use, or leave them on the main computer, or erase them.
And not only can he use his micro to read the messages colleagues have left for him from wherever they might be around the world, he can also send his own.
I can send group messages to a bunch of different people, but if I want a message to go to a person, then only that person can read it. The message arrives at the main computer, and it sits there in storage, waiting for the person to read their mail. Having a computer at home means that I'm able to edit messages myself. I don't have to depend upon my secretary to retype things for me 3 times. It also means we can talk to people around the world without having to worry about what the time zone is and whether he's up now or whether he's even in the office. And I know the message is going to get there and not be garbled.
Today we're going to look at how computers can be made to talk to each other, and in particular how they can become a powerful extension to your telephone. But not just for the kind of electronic mail we've just seen. By the way, if you've got a BBC Micro, we'll also be linking our computer here in the studio with yours at home by sending you an end-of-series message as a computer program. We're going to transmit it as a sound, so you might like to get a cassette recorder and a microphone ready to record it at the end of today's program. Well, first of all, let's see how we can link micros together over a short distance, say between a couple of offices. With us again today is John Cole. John, what's the setup here?
Well, Mac, we've got a network of computers here over a very small distance, and all the computers on these benches are connected via a set of cables here. The cables just plug into the back of the computers. Now, they enable the computers to communicate with each other and to communicate, for example, with this unit down here, which is called a file server. And the real purpose and beauty of this system is that all users can then access the disks which plug into the file server here. In addition, all users on the network can connect to the printer and use the printer facilities. They don't have to have one each.
This file server is just, in fact, 2 disk units. Really.
That's right. And if you type catalog or StarCat on your machine, I do the same, we can both get a catalogue of the disk, even though neither of us actually has our own disk unit. Now, this system can be used over quite a considerable distance, say up to 500 metres or maybe even 1,000 metres.
Yes.
So really quite useful. Well, would you like to load your program, the one called Mac, and I'll load mine. At the same time, John, and they come down. Notice apparently everything working simultaneously, despite the fact that we're connected to the same network. Run the programs?
Obviously quite different programs.
That's right, totally different programs.
And what sort of speed are they transmitting at?
Extremely fast indeed, a lot faster than you can get over a telephone line. A very usable system, really. Now, as well as that, we can actually use it for a certain amount of communication. In fact, if you stop your computer, I can send a message over the thing. I can say, notify Mac, hello, how are you? And then when I press the return key, that message will go down through the network and appear on your machine.
So I suppose we could actually put these out in different offices, on different floors, or in different classrooms in a schoolroom.
That's right, that's exactly what it's about. It's about sharing the resources within an office situation or within a school situation.
But if you wanted them much further apart, you'd have to go through the telephone network.
That's right. Well, over here, we've got a setup using telephones. Telephone network, obviously, is a worldwide network, so you can actually communicate using the audio tones down the telephone line.
In more or less the same way as we did with the cassettes. And this is a little demo we had which showed how, when we're reading it in from a cassette recorder, you're going to see it more slowly, that the tones are actually fed into the ons and offs into the computer, and of course the computer can do the same sort of thing. And we use that same principle, really, to transmit programs or data over the telephone.
That's right. In fact, you get the computer to connect to this device, an acoustic coupler, and the acoustic coupler can be used to generate audio tones which go down the telephone. In fact, I can show you a demonstration which illustrates that quite nicely. Wherever you have two users, each having their own telephone system, then it's possible for each of those users to link into their local telephone and transfer stuff across. On this illustration, we've got a program or a piece of text up on the first computer. If we join the two together with an ordinary telephone line, then that text or program can transfer across. In fact, I'll just show you that on this acoustic coupler we've got here. I'm loading a program into the computer which enables the computer keyboard to control the output from the back of the computer and into the acoustic coupler. And if I turn the coupler on, it generates a tone. And if you press some of the keys, you can hear a very short little bleep, and each character is sent out as a very short bleep.
And that's running at about 30 characters a second.
Yes, it is. It's relatively slow, but nonetheless quite usable. Now, in fact, we can use that to communicate exactly as I showed to another computer, and you've got one over there. Can I dial via this telephone, dial you up, and try to talk to your computer?
Well, this time you really are going through the British Telecom's network. You're dialing through to an exchange and it'll actually come out here, hopefully if you get the right number.
I'm trying. Have I got the right number?
John, hello. How
Amazing. Let me send you some tones.
Yes, that's good. Excellent.
Right, so now the two computers should be communicating.
That's coming through well.
Amazing. Don't put me off.
Hello, Mike. How are you? And I presume I can send the message back, and by typing it, you'll receive it immediately. I am, surprisingly enough, still great.
A wonderful system, right?
Well, one use of this, of course, would be to transmit programs from one computer to another, but you'd have to be very, very careful because there's no error correction or detection on the line. You could have a lot of errors, and I suppose two deaf people could use it. Rather than speak on the telephone, they could actually type to each other on a system like this. But actually, for sending messages like that, it'd be crazy because I'd actually have to be there to answer the telephone. If I'm going to answer the telephone, you might as well give them the message anyway.
Yes, it's a real problem. You need something far more sophisticated, an electronic mail system. Now, electronic mail means that you have a large number of computers all over the country or all over the world, and those computers